Hello and welcome to the Stratosphere Chamber at Brooklands. I'm John Rowland. I am a volunteer who've worked here in the Stratosphere Chamber since it was reopened in 2014, and I was in practice in March 2014 it was opened, and in April I started coming here as a volunteer, not realising it had just been reopened, and I stuck with it. So that's now 10 years that I have been here as a guide and volunteer at the Stratosphere Chamber. So the Stratosphere Chamber is, as you can see here, Barnes Wallis Stratosphere Chamber. It was conceived and designed by Barnes Wallis in 1946 as a way of trying to test aircraft, Vickers aircraft at that time. So first things to do is to come in through the main entrance, through our heritage doors, the original doors to the chamber, and we will then work our way through into the main part. So please follow me. And as it says here, inventing the future, the innovations of Sir Barnes Wallis. So the Barnes Wallis exhibition was basically opened about a year ago, so we have a lot of newer signs over some of the previous videos that have been done, so things have changed a little, which is partly why we're doing our introduction again. So as we come through the pigeon proofing, we are come and see the chamber itself. Okay, so as you look in here, the first thing you will see is this rather large object in front of you. Now, we usually ask the visitor as they turn up, what do you think you're looking at? Now, the usual answer is the back of a rocket. And if we had £1 for every time we got that answer, we'd be rich. However, it is not the back of a rocket. What you're actually looking at here is a 70-ton sliding or rolling door. So that is the door to the chamber. Now, many people think when we say that the door pushes away and the chamber is behind there, but that's not the case. It actually slides along on rails, and we'll look at that in a minute. And to our, or your right, left, sorry, my right at the moment, is a big black box, and inside that box is the chamber itself. And we'll come to have a look at that shortly. Okay, so why does it exist? Well, it's all down to this man here, and he says Sir Barnes Wallis. At the time he wouldn't have been Sir, but the man here shown in this picture is Barnes Wallis, and at the end of the Second World War he was thinking, like no doubt many others, of aircraft that will fly a long way, to be able to fly to the other side of the world in a few hours. To do that they needed supersonic aircraft. And the model he has here is one of his early concepts called the Swallow, which would be a supersonic aircraft. Now, you also have to fly very high. Now, if you're flying high, that means you've got very little air and it's very cold. So the problem that presented to Barnes Wallis is, well, we don't really understand what that conditions will do to the aircraft structures. So he wanted somewhere to be able to test on the ground for those kind of effects. And that's why he conceived of this Stratosphere Chamber in 1946-47, and it was developed from there. Now, what you actually see there, as I say, is about 70 tons of steel. Now, the actual construction of the chamber, which can be shown by the pictures we have here. So it was all done, basically all the parts were constructed and the details were put together by the Barrow in Furness shipworks of Vickers. Now, in the Second World War, Barrow in Furness was a shipbuilder and submarine builder, so they were ideal people to try and put together a stratospheric chamber on the basis of dealing with rolling of steel and, of course, the ability to design or detail a structure that will be able to stand 1 atmosphere potentially. So in the pictures we have at the top right, that's a picture taken at in Barrow, and there's some ductwork being constructed there. And then the picture immediately to the left, the parts were then brought down from Barrow, about 10 tons potentially a piece, as you can see on a trailer there, And we reckon it must have taken probably 2 days of travel to get them all the way down. Now, when they came down here, this was in 1946, there was a slight problem that, as you can see potentially from this picture here, the foundations which were put together, or they started working on in 46, the winter of 46 into 47 particularly was the coldest of the last century, so they couldn't complete the foundations in time. So what they did was to start working on building the chamber itself, and there's a picture up here on the top left which basically shows them sort of winching parts together. But if you look in the background particularly, you can see the snow fields. So say this was early 1947. So they basically had to construct the thing, bringing it all together in the very cold and snowy weather. But finally, they managed to complete it. And I say this picture here now shows the complete chamber. So it's been built about 50 meters away from where we are, around there. And you can still see the snow piles there. So this is probably getting into spring of that year. But well, having completed the foundations, the picture up here then shows the process that they had to take to literally launch the chamber across these wooden planks and basically slide it into position over the foundations. Now that took them about 20 minutes, I'm told, and I suspect he was actually stopping it rather than getting it going was the main problem from what I've seen from some of the video that we have. Having got it into position, there's a picture down here showing it with the the structures underneath just about being put in position. And what you then had was that the shed was put around it. So this is the big shed around here with the due concern for health and safety. And I do hope they tied off that ladder. But so by end of 1947, they had a place basically enclosed. Now, the picture we also show to people as they come in to make them understand what's going on is this is a picture of the naked chamber. So this is the door that we were looking at a minute ago, and this is the rest of the chamber that's in the big black box. So now I think we should take a little trip down through the plant area and we can have a look at the door. Okay, so now we've seen a few pictures there that show the construction to the point where we have a shed. But the rest of the material in here is all the plant that had to be put in to be able to provide the appropriate conditions within the chamber. So as we walk down this way, you can see various parts of the plant. And on the right here is a large condenser which has been cut in half. And on the other side, we have two compressors, beg your pardon. So there's one compressor over here. And in the middle, we've got the various gauges to actually monitor the conditions and of the refrigeration. And there's another compressor. Now, originally there were 4 compressors. We've lost 2, which were sold for scrap and rescued the museum during the 1990s when they were basically broke. However, we've still got quite a lot of bits and pieces. And on the right here, we have an example of what's known as an evaporator. Now, if you put compressor, evaporator and condenser together, you have a refrigerator. So effectively, we have a very large refrigerator. It's slightly complicated the way they had to do it because they could achieve down to minus 65 Celsius. So that's more than 3 times the freezer in your home. Now, to get down to there is rather complicated because they use ammonia, and ammonia freezes at about minus 30. So they had to use some rather unusual low pressure secondary system to be able to get the whole thing to go back to minus 65. So that was quite complicated in those days. Down here we have examples of 2 of what was ultimately 3 vacuum pumps. The big one in the back with the red cage is the original one. Now these were not located here but on the far side near the door where we came in. Now originally there was just the one, but they always allowed for having 2 extras put in afterwards. Or in fact I think they allowed for 3, but they did in the end put 2 more in. This allowed them to bring the pressure down much quicker. So as opposed to the, shall we say, the cold side, it took 24 hours plus to be able to get it down to quite low temperatures to minus 60. You could do a pressure cycle within about half an hour with the 3 pumps. Now, the combined effect of the pumps would be to be able to get the pressure inside the chamber down to about 0.05 of a bar. Now that's 5% of normal atmosphere. Now that, with the temperature, is equivalent to about 70,000 feet. And that was, originally I believe the target was near 100,000 feet, but 70,000 was achieved due to leaks and other problems that they would have had. But 70,000, as you may know, is quite high compared with standard aircraft, commercial aircraft these days. So it easily covered the range that ultimately was necessary. Now, as we come down here a bit further, we get much closer view of the door. So the door is known as the Great Chamber Door. And as we said, it's 70 tons of steel. And as you look slightly to your right, you can see some bogies effectively. Now those bogies are running on rails, which is what allows the door to slide or roll across in front of the chamber, which is in the black box, which you can just about see in the background. Now, how they moved it? Well, if you look through here, you can see what looks, well, I always think it looks like a capstan wheel. So that, and two of those with gearing, which allow you to be able to move the door. Now, originally it was entirely manual, and I moved it about a year ago, so it still moves. I didn't move it very far, admittedly, but I think the rails might not stand it at the end these days. But a little bit later on, they did put an electric motor in there to make life easier. But it was all manual and took about 20 minutes to close. So once you've closed the door, you have to move this part of the door against the main part of the chamber. And very originally, they designed a system with a big, large, long ram, which basically took against the back of the wall and pushed the door against the chamber. Unfortunately, that didn't work very well. So they then put in some rams, and you can just about see the rollers there to allow the door to move backwards and forwards. But there are a pair of hydraulic rams, of which there's one there, which were then used to jack the door forward to its nominally closed position. Now, I think that was slightly more successful, although not totally successful, so they did in the end put some nuts and bolts to allow the whole thing to be clamped together. But so I think by the end of the mid-50s, they just about sorted out to be able to close the thing. Now, the other interesting feature you might be able to see here is all the pipe work that is sort of sticking out. Now, the pipe work is the means by which the cold was circulated round to heat exchangers, of which you can see the bottom of a square box at the back there. That's one of the heat exchangers. There are 16 in total, 8 on the door here, and there are another sort of 8 mirrored in the back of the chamber. But the key point about these pipe work is that the material they used was methanol. Now, methanol, as you may know, is quite, well, it burns with a very clear flame, you can't see it, and it's extremely inflammable. Now, every time you opened and closed the door, you had to undo and drain the system down. So you had methanol sort of flowing around the place quite freely, and I'm told these heat exchangers used to leak like bilio. So you basically had huge sort of ponds and pools of methanol around underneath. Now, as we go back, we will be able to see one of the things that required of the chamber design. As a by the by, as we're coming back this way, you may notice this slot in the ground. Now, we only discovered a matter of a couple of months ago what all this was all about. We had never known why it was done the way it was. We had to lift the wooden top because it's basically fallen apart and rotted because it gets a bit damp around here. But underneath, you may see what looks like bricks of some sort. They're actually, that is cork. So these are slabs of cork put down a hole. And if you go down the deeper bit, which we can't fully see, it goes down a long way. And it was only then that it occurred to me and others as to why we had this slot around here, which in practice goes all the way around the back. So it's hidden slightly underneath the education centre, but it goes all the way round. So what this was is an isolation gap for the mount where they put the compressors. So there's a very deep foundations here, and you've got extremely vibrating equipment on it, 4 lots of compressors and your vacuum pumps. So that they needed to isolate all that vibration from the main part of the chamber. So this slot had been put in to actually provide that isolation gap. As I say, that was something we only discovered a couple of months ago, when we had to take a few bits apart because of danger of things falling apart and rotting away. Now, as we come back down to our front end, there was something I wanted to point out on your right here in this cabinet. It's a little bit of history, shall we say. There's a little model shown there, which is the R100, which was the chief designer of which was Barnes Wallis, or later Sir Barnes Wallis. And I came in here one day, and many years ago now, and I met up with this lady who turned out to be Elizabeth Barnes Wallis, although that wasn't her name at the time. She got married, but she basically said, "Have you got any of the stuff that we donated?" So I came round here and sort of showed her this cabinet and said, "Oh, I recognise that. That's the toy we used to play with on the ground, which my father brought in home for us." There's a few bits missing, I think, off it, but it's quite a nice German-made little tin toy of the R100. So that's a little by the by. But anyway, as we come round here, we pass the picture of the Swallow, which never actually happened, although many of its concepts, including variable geometry, did come into aircraft later on in Barnes Wallis's world. But what I came back here for particularly was to show you these. Now, that would have been one of 70 bottles of carbon dioxide. Now, if you stay there while I grab something here, this is part of the insulation material that's used in this big black box. Now, it's very lightweight stuff, and it's basically made up of something called ebonite. It's aerated, but it's vulcanized rubber. So this is vulcanized rubber, very lightweight, and a lot of air and stuff in there. And as I mentioned earlier, there was quite a lot of methanol that used to flow around the place in there. Now, later on, they put in heater banks and things under there. So there was 200 kilowatts of heat that could be generated. And that did allow them to take the temperatures up to around about 50 plus centigrade. So they could test hot as well as cold. But if you've got basically this stuff, you've got methanol and you've got a lot of electrical gear, there's a fire risk there. And they did recognise that there was this problem. And between this box and the actual chamber, which we will have a look at later, there's a void where you could have quite a serious fire. So they designed, or a company called Pyrene, designed this fire suppression system that would basically snuff out any fire that would occur. So as I said, there's 70 bottles of CO2, and if one looks down there, you can see the sort of the long run of all the bottles. Now, if there was a fire, this could be operated from either upstairs in the control room or from here. So here you've got the system to basically a deadlock to stop it from going off accidentally. But once this is pushed out of the way, like that, you've removed the little deadlock. Now, this here now is active, and we have one of the bottles sort of linked up as it would be. But if you now scan back a little bit and I pull this, you will see what happens. So that was one of those rods coming down and pulling open the bottle. Now, if it was in real life, as it was designed, that would have been 70 bottles going off and evacuating themselves in probably 10 to 20 seconds, I would guess. So all of that CO2 would then be pumped through the holes in the wall into the inside, and there are a little distribution network inside, which will then have flooded that whole area and put the fire out. And as I did mention, methanol does burn, or you can't see it burning very easily. So I'm not sure how long they would wait or how they would consider going back in afterwards, particularly given you couldn't breathe in there because it was full of CO2. So anyway, they thought of a lot of things, and that was one of them, how to put out a fire. It never had to happen in real life that we're aware of, although I'm sure they did test bottles occasionally just to make sure it was still potentially working. Okay, so that really is the whole sort of the plant area that we have here. And the last item to probably mention is not specifically to do with the plant, but there's a tower on the left hand side you can see, which is painted green, which actually is not the right colour, but there are two large motors up there. Those are big DC motors which drive fans, which allowed you to circulate the air around the chamber. And as you can see in the door, there are two lots of ducts, one each side of the main part of the chamber itself. And the air would have been circulated through those, then back through the chamber, which is 25-foot diameter, and the chamber is about 50 foot long. So that's about 7.5 metres by 15 metres in modern language. So having looked at this area, we now need to go round the corner and have a look at the other aspects around the back of the chamber. As we move round the corner from the plant room, as we just had, you will see this door here, which says no admittance unless accompanied by a member of RD, which is Research and Development staff. Now, there's also this test in progress sign, which isn't quite true, but it makes it look prettier. But this is the ground floor access to get into the back of the chamber. Now, there are two pressure doors that were put in, one which is about 2 meters up from this level, and the other one which we'll see later, which is upstairs, which shows well, it's equivalent of one of the two. Now, this would be the normal way in and out when they've got doing tests on the flat level at the bottom of the chamber. The other one is used where you actually have larger objects in there and you wish to walk in and out of them. So if you went through here, and we can probably see the other side of that later, you will basically see that you can get up to a platform and into the back of the chamber. But as we then move slightly further down here, the other item that we can see to your left is what appears to be wooden doors. Now, these are quite not flat doors as we have on the other corners, but these are doors which allowed access to the heat exchangers to allow them to service them as necessary and presumably plug the holes that used to appear every now and again, which is why methanol used to leak out of them. Now, so they had special doors there which are all insulated again with the ionozote, the same as the door, but you can remove those panels for maintenance purposes. And again, as we continue on down here, we have what are the steps to the upstairs section. And as it says there, please be careful, steep stairs, and that's an original sign. So they clearly had some problems sometime in the past. So let us now go upstairs and we'll have a look up there. So we've now arrived at the top of the stairs, and originally this was a little platform here, sort of up to the point where you can see the difference between the flooring. So this was just an area where you could come, a little platform, and to my right, your left, is the control room. But we will go in there in a minute. But basically, we go up the bridge, as I tend to call it. This allows us access to the the upper airlock. Okay, so as we go up the stairs here, we come through into the first of the pressure doors. And I always think this starts looking a bit like a submarine as you come in through here. So you have a large pressure door, and in the distance you can see the second of the pressure doors. So if you were trying to go into the chamber when it was at reduced pressure, you would have to come in here at atmospheric pressure and then slowly be taken down, or up arguably, in terms of the pressure. Now, deep sea divers have a problem when they come to the surface in terms of getting the bends, whereas the workers here, their problem was actually getting into the chamber as the pressure reduced. Coming out wasn't the same problem. So effectively you could get the bends if you were going into a slightly depressurized area. So as we move through the airlock, we're coming to the door, and in front of us is a piece of a Vanguard, which is just in there as an example of the sort of thing that was tested in there. So the Vanguard was tested here in the mid-1950s, and whether we can actually see it very easily, I'm not sure, but as we look through the door, and if we can look back at the plate, I'm not sure if we can actually see much there, but what you should be able to see is there's a ring with bolts on it. Now, that ring with bolts is how they would attach, or could attach, should I say, a large object to the back of the chamber. Now, in doing that, you could seal it to the back of the chamber, so allow yourself to get in and out at lower pressure inside for example, a part of a Vanguard, as you can see here, or VC-10, while the outside pressure was varied. Now, that would allow you to be able to monitor the structure as it was being tested. Now, they did have a couple of incidents, so they did tend not to go inside pressurized or unpressurized areas where you've got low pressures outside, because if you had a failure you could end up being sucked out. So this was the way in upstairs, and the airlock itself is the same as the one downstairs, which is at the floor level, which you can see down there, which in the airlock itself is immediately below us here. Although we can't actually get to the back of it as we saw the door as we came down, because basically that area is inaccessible at the moment. As we've now come to the bottom end of the bridge, as I call it, we are walking our way into the control room. Now, it's as it tells me here, but as you come in here, it's quite an airy place in many ways. It's called the control room. In practice, it was more of an area for monitoring the experiments that went on here, and that can be shown by these terminal blocks all over here. So it got up to box N from box A on that side, and there would be equivalent connections within the chamber. This allowed you to put instrumentation inside and put the other end of the instrumentation on this side. And as we can see, there are recorders up here for temperature, which haven't moved for many, many years, but they probably would still work. And as one comes further across, I have some items here which we'll talk about in a second. But again, we're talking about here areas for monitoring. So you have here what are a test for temperature. Now, some of these still work. And as it says down here, you've got fan gearbox, and it's talking about 11, 12, 13 and 14. Now, I believe, if the batteries are still working, if we press onto that one, the little dial at the top now has moved across, and it says it's 47 degrees Celsius, that is. I'm not sure that's quite correct, but it's still pretty warm up there. So that's number 12, number 13, number 14, and I think if we press number 11, bonk, no, it's not working. So these three of the other ends of these are actually still connected and still working. I don't know if any of these others are still connected to the other ends, but they don't work at this end. But as you come across, that would have been a way of measuring temperature in various parts of the equipment and inside. Here you have a barometer, which originally was a mercury barometer, which we've simulated with a slightly different one. But that would allow them to make accurate measurements of temperature. So that was an instrument grade barometer. And as we come across, we have the equivalent of the controls. So this basically has a valve which was connected to down below to a valve on the input from the vacuum pumps. And there was something which seemed to have been called the waff-chuff valve. And I'm pretty certain that's what's down below. And it's an onomatopoeic because it probably went oof, oof, so they probably called it a waff-chuff valve. But that would have been releasing the pressure, so using this you could actually monitor the actual altitude within the chamber and quite accurately control it. Moving along further, there's some bits missing from here unfortunately. We have what is called the circulation fan controls. So as we mentioned, we have the 4 ducts. Each duct has a fan in it which is connected to a motor. The motors are DC motors and this enables them to control their speed. So there's here a overall overarching control which unfortunately isn't connected at the moment, whereas you've got 4 controls for each of the individual motors, and these are still connected to the relevant devices below there, and you can see it moving. The key point here was to be able to monitor the speed of the air, and as you varied the speed of the air you could actually vary the temperature. So there's a coarse temperature basically caused through the refrigeration system, but as the cold goes into the individual heat exchangers, if you push more air through it, you would end up getting the cold chamber down colder. So you could actually do a fine tuning basically. So that was what this was all for. And then at the back here, there's areas where they could do monitoring or whatever in terms of books like this, which actually, this is from a Vanguard test cabin, as it says on there. And it covers a period from January the 21st through to, what does it say, February the 3rd. Now this, I don't know if it has, yes, 1959. So that was a log, and there's many, many pages of it, and for covering the months, potentially end to end, of testing that they would have been doing. Now, as we move along here, we have some examples of the leaflets that they produced, basically. Now, literally this morning, I found one which isn't there. So I have examples of the other ones shown here. So this is about 1954. This one, the one in the middle, is about 1968. And the one at the top there is about 1972. And these are genuinely the old copies. They've not been reproduced. But then I found this one, literally this morning, which says it's from the 5th of March 1954. So that's a reprint. And they notice they call it the Big Flask for some reason. Now, when they moved on to actually make this, the equipment, or shall I say, advertising it through Vickers and then through to BAE, they started talking about high altitude climatic simulation and things. But for some reason they wanted to call it the Big Flask. But it's interesting to note that this particular article, which was, say, 1954, appears to take a lot of data from very early on, and the sort of things they were doing just after they'd started work in the chamber. And we know it's quite early because there's a picture in the corner down here which shows under the chamber, and there's bits missing in there, which is the supersonic wind tunnel end, which we'll have a look at in a minute. But this particular flight magazine leaflet is almost the same. It's just a lot simpler in this one as to the one that Vickers had put out, and they were calling it the Stratosphere Chamber, but the pictures are fundamentally the same pictures. There's a very limited set of information which I guess they might have been looking to preserve some of their some copyright in some ways in terms of the actual performance for the chamber. But as we look in the back, for example, there's a whole load of information about the attainable conditions, and they refer to the minus 65 Celsius, and they say at least plus 55 Celsius. Other reports indicate it's more 40 to 50. That may be on a nice hot summer day like it is today when we're filming this. But again, as we go back, there's various different conditions they could achieve. And one of the interesting things potentially here is they could inject water into the system up to a 45 knot wind at sea level, and the rate of 1.5 to 2 tons of water an hour. Now, if you start cooling it down, that allows you to simulate snow, ice, hail, and very nasty conditions, which is what they were doing. And I believe that's partly shown here by a couple of the photographs you see. And the slightly later version, it actually refers to a number of things that were tested in here. So it talks about trawler ice accretion. It was a fairly famous, inverted commas, experiment that was done, there's a picture there showing it, with the trawlers that were sinking in the North Sea. And they were basically looking to see how they could re-rig them to stop them capsizing when you've got ice accretion on the masts and all the other high-level equipment. And again, you can see there's electrical equipment here, and that was probably for testing for Arctic and cold conditions. And similarly, I think that might be a naval gun all covered in ice, but I'm not entirely sure what that is. So there's a whole long list of people who've worked in here and the sort of kit that they've actually were using in there. Now, as we're leaving the control room, I thought it's worth looking at this particular photograph, which is blown up from, I'm not sure exactly when. I would guess that was probably in the 60s, but I'm not certain. But the interesting thing is it does show some other pieces of kit which have gone missing. That's where the proper mercury barometer was. It's a very posh looking device there. As I said, it was a true instrumentation. But again, that shows people working and looking at things, and you can see there the guy has a headset. So all round the chamber there are plug-in headset points which allow them to communicate as necessary. There are also wind-up telephones which we've talked about in other videos, which we can but there are various different ways they could try and talk to themselves, people around, the people who looked after the plant and so on. But then here there are a whole load of pictures showing the different type of stuff that was actually tested here. The trawler experiment, which we mentioned in the past, and then as you can see here you've got heated bridge windows, so that's presumably why you can see through that one. And then you've got various other guns and anti submarine, I think that one is, yes, weapons which would be tested for ships. You've got cold equipment in terms of electrical points. There's 3 pictures there. There's a bridge carriage. There's the front end of again a Vanguard, like the one we've got in there, except that was a test one. And then, not easy to see these ones, but other pictures of military type aircraft. So you've got the Scimitar, the Supermarine. You have here the Sea Vixen, the Sea Vixen, which I'm told there was difficulty to getting that one in, even with its folded wings, because the width of the chamber was a bit narrow, so it had to go in at a funny angle. And then you've got helicopters, and whether one can actually see the picture down there at all, I don't know, but that looks like it might be. So that is testing for UV, so they've got an object in there with all these UV lights all around it, so they'll be testing it for UV in cold temperatures and so on. So that's kind of covers a number of the things they did in there. There's a lot of other things, of course, that's not mentioned in there. And I mean, from a Vickers point of view, they started testing their aircraft from the second mark of the Viscount, the Vanguard, which we mentioned. And then the Valiant bomber came along at a similar time with its pressurized cabin, which was tested fully in there. Slightly later on, you had the big test program, which would have been VC-10. VC standing for Vickers Commercial, so that's VC-10, and the aircraft which ultimately went to the military in quite big numbers to do things like refueling, and it's about 10 years ago now since the last one retired, so that took a long time, from 1960s down to about 2010. You have the 111, and then the one that people often get wrong is they say that Concorde was tested in there, and now that wasn't quite correct, because the full testing for Concorde was done at Farnborough down the road, and the big issue they had there wasn't cold, it was hot. So they had a huge hangar where they had a complete Concorde where they could heat it up to about 120 Celsius outside and then plunge it down to sort of much lower temperatures to actually measure the expansion and contraction of the skin. Now they couldn't do something like that in here. There were bits of Concorde that were tested at Vickers, and a supersonic wind tunnel, which we will come to shortly. Then there are parts for the air intakes for the engines are all tested and developed there, which there are various stories I've heard from a certain person who's still around of Barnes Wallis coming in, looking at what they're doing and saying, that'll never work, and then telling them what to do, and it did work after that. So a little diversion from where we were in the Stratosphere Chamber to an item which is directly related to the chamber, which is this VC-10 part. So this is a front end of a VC-10. Something's trying to take off in the background from what I can hear. But this was the test section used in the chamber, and basically ultimately passed all its tests. As the reason we know that this is the test section is if one comes around the back side. We did mention earlier about a ring of bolts which allowed them to connect the back of an airplane section to the back of the chamber, and this is the evidence that this one was used in the chamber, because it's got the other ring of bolts on here. There would have been a part in between that bolted it all together, and a little access door which has got sealed up later on for reasons we might mention in just a minute. But this shows that it was the part that was used in the chamber, and they bolted to the back so you could then walk in and out as you were testing it. Now once it had passed all its tests, this particular part was then taken outside They filled it with water, pressurized it, over pressurized it until it went pop. So there was final test was the factory destruction test. My understanding is it failed at about 1.5, which was the target, although it's apparently a couple of percent below what it should have been. But they weren't that worried about the odd percent when you're already at 150%. So again, this is the only large part remaining that I'm aware of items that got tested in the chamber. So if we go back now, we can continue the tour around the rest of the Stratosphere Chamber. Okay, so as we work our way round the chamber here, and having looked around the back, it kind of reminds me that originally the whole of this facility, including the shed and the chamber and all this, cost about £232,000 in the day, which is say late 1940s sort of prices. We think that's approximately about 10 million in today's money. But I mean, if you consider how much there is in here, and you've got the shed and everything, then that it really is quite a cheap price. But then, given that this was just after the Second World War, I'm sure there wasn't a huge amount of work going on up in the Barrow furnace with the Vickers, so they probably got a pretty good price for constructing the thing. And having talked about construction, if we divert underneath here to where it says no public access, but then we're not really public, we can then get under here and we can have a look at the underside of the chamber itself. If you come on a day and talk kindly to the people who are volunteering, they might let you have a quick look under here, but it's not normal. So as we come in here, trying to avoid tripping over the ramp as we come down, what we have here is the underside of the chamber itself. And as we saw the big black box going all the way round, so inside the black box is this very large space, and the big tube you can see in front of us here, which runs all the way along, is the main part of the chamber. So as we kind of said, the chamber is about 20 foot, 5 foot diameter, or 7.5 meters, and about 50 foot long, or 15 meters. And we can see basically all of that under here. And similarly, as we look up, if we can see one of the main ducts. So these are the circulation ducts that we had mentioned earlier. And there are two on top of each other here. Okay, so having seen the ducts up there, if we move through underneath, and I'm not quite sure exactly what height it is, but it's less than 6 foot, but people were smaller in those days. But if you come through to the other side, we have a similar setup of the ducts. So we can see the lower one of 2 ducts, and just about with this light you can actually see further up, and there's a second duct sitting on top. And as you look into the middle of these ducts, you can see the expansion joints that were in there, because, as we've said, you can get down to minus 65 Celsius, but also you could get up to 50 Celsius underneath here. So that's over 100 degrees. So there's quite a bit of expansion. So you need a little bit of a expansion joint, shall you say, to allow things to move. Similarly, the pipework on here, if you look to the left of it, you can see what are known as swan necks, which again are to do with the expansion to allow for 100 degrees difference. And the other item we can see under here is the heating system. So basically the square box we have over here is where the 200 kilowatt heaters work. They still exist in there in practice, and there's a large fan motor to actually drive the air through the fan, through the heaters, and the heat could then be ducted into different places where you actually wanted it. Generally, I believe it was just came underneath here, so there is a pipe you can see that's sticking out towards us a bit. That's where the heat would come out, and the whole of this underside would be heated up to 50 degrees C, and it'll work its way into the chamber. Now, the other thing we can see in here while we're here is there is a light device. There's a light up on the hanging from the ceiling, which hopefully you can see. But it's a specialised light. It's an explosion-proof light. As we've mentioned, you've got methanol under here, so there's quite a lot of methanol in all the electrics. So if you did have a fire, or should I say the lights wouldn't be able to cause the fire because the heated bulb is held within a little glass envelope. So that's another one of the features had to put in to make operating as safe as it could be. And as we come through to back to the first side that we were in terms of the chamber, back from where we came just now, then another item to show here is an item here we can see to your left. Now there's a tube coming out of the main part of the chamber, and again some expansion joints which you can see to the left, some rusty bits, and then it seems to disappear outside. Now that's the stub of the supersonic wind tunnel. The wind tunnel itself was installed in 1958, so that's sort of about 7 years after they started using the chamber in 51. And it was used through early parts of the 60s to do supersonic testing for structures, or shapes should I say, for example for Concorde and for TSR-2, and potentially for the Tornado variable geometry aircraft known as the MRCA originally. And it was then apparently, it more or less got disused sort of into the early 70s. So that was about, let's say, given the overall life of the chamber was from 1951 through to about 1982, then that's about a third of its life. Then it could use this supersonic wind tunnel for experiments which did quite a lot to develop the shapes and the requirements for Concorde, in particularly the air intakes, the ramp air intakes. So that's one item which was a modification, shall we say, that was put into the chamber. And a lot of other modifications were made over the years to make life easier. But one thing we probably ought to have a look at as we go out is to have a look at the far end, because we can actually see a little bit about the lower airlock and how people used to get in and out. So as we've moved through into the far end of the chamber, as we were looking at it just now, this is, you could argue, the back end of the chamber. The big door is at the far end, and this is where the other equivalent turnaround happens for the air going through the ducts. So if you look up, you can see at the bottom of another one of the turning vanes and heat exchangers. So this is where the air would have been turned round and then comes round another heat exchanger immediately above me, and then it disappears back into the chamber. So that's just an example of the U-bend, as one of my colleagues calls it, rather large U-bend, which allows for the air to be circulated round. So in practice it's coming out of the chamber, around, and then going down the duct to the front end, to the door. Now the other thing we can see in here, apart from another one of these fire-resistant bulb heat light fittings, given that that's missing the glass shade that's on the outside, is next door to it we have what looks like a black box. Now that black box in practice, and if we can see a little further across to the next one of these, because there's several of them as they go round, what you can see inside are rollers. So that is how the chamber allowed for expansion at the back here. So when the chamber expanded, the whole top part of the chamber will move towards us. Theoretically, the structure is standing on stage sill, and then the rollers allow for the chamber to move the inch or so that it would need, or 25, 30 millimeters. So they put all these round at this end, because this end moves. The far end is fixed where the door is, because you don't really want that moving when you're trying to push the door against it to actually make a seal. Referring to seals, the reason for the seal is this pipe here. because this is the access point for the vacuum from the vacuum pumps that we saw earlier. So they come through a trough up through this large pipe and into the back of the chamber. So that's where the air would be sucked out. Moving slightly further over and not tripping over the pipe as I go, but immediately above me now, and I'm sure quite what you can see, you've basically got the lower airlock. So this is the way people will generally get in and out. This is to the floor area in the chamber. So you had to get up on this platform and then open the door and go through. And I'm never quite sure how they managed to get up there. I suspect they just had a simple ladder system to get up, and you just had to mind your head as you were coming through to prevent yourself hitting your head on the heat exchanger up there. But the other things we can see down here is a whole load of all the pipe work, which is basically circulating methanol through to the heat exchangers and so on. But given those pipes, and at the back there's a doorway you might be able to see, that goes through to the door we saw at the back of the chamber, which said no entry, experimentations in place, or whatever it said. But basically that's the way you would normally get in and out of the chamber. And then finally, immediately above us here, we have another pipe. So there's a pipe there with a valve on it to seal it off. That was used basically to remove things like exhaust gases if you were running like a diesel engine within the chamber. If you wanted to take it down in pressure, you would have to seal that off, because basically that's just going outside and is like an exhaust pipe, as it were. And so as you were doing experimentation, if you needed at a normal, well, shall we say ground level pressure, if you needed to suck out air to remove gases or some other noxious substances, then you could use that as a way of doing it. And similarly, which need to turn all the way round, and hopefully you can see, there's something which we only exposed down quite recently. There's another pipe coming down here, and then there's a little box at the bottom, and that was another inlet. So that was another way of ventilating this area, given that there's probably methanol fumes all around here. So you could suck air out of here quite happily and it was exhausted somewhere over where the Vickers suite currently is. So that was just another way of trying to keep this area slightly purer, shall we say, in terms of air. Although the place would have reeked of methanol, and certainly ammonia would have got through into here as well. Okay, so that's the back area of the chamber and our little diversion underneath. So we should now be able to clamber our way out of here, which is a little bit of a clamber at times, and then we'll continue on the way round to see the front end of the chamber. Okay, so as we've come out from underneath the chamber and the door back there, up the ramp here, this used not to be a ramp, and there were just stairs basically under here which could get you onto the platform in front of the well, the door runs on that section. But I thought we ought to stop and mention this thing here. This is the stub of the Supersonic wind tunnel. Work on this started in 1958, and I remember that because I was born in 1958, and it went into service late 1958, and they were using it to test aerodynamic shapes and so on. And at that time they would have been looking for things like TSR-2, which was one of the famous aircraft that never made it from Vickers, cancelled in 1965. However, Concorde shapes and various parts of Concorde would have been tested in the parts that were attached to this stub. And indeed the little model in there actually shows from 1964 what is known as the Vickers Supermarine 589, which was a variable geometry aircraft. And I said 64, and that was in the direct lead up to the Tornado via the multi-role combat aircraft, MRCA. So that's some of the things that were tested in here, including things like missiles. But here you have some pictures that actually show how it was put together. In particular here, it's not accurate, but we're standing here, but this valve actually is on the wrong side. But coming through here, you have the Vickers suite, where you have basically these tunnels, the Venturis and so on, which are the main test areas. And then going further on, we have what's called here the balloon hangar. Now this is where McLaren exhibit currently exists. And basically, if you had a vacuum in the chamber, you could have a large volume of air in a balloon, and I think it was a barrage balloon that he used, which allowed basically normal atmosphere, about 15 psia, so it's just above to inflate the balloon. And then basically, if you remove the valve out of the way, you could have an airflow going through into the chamber. And he talks about here speeds up to about Mach 4. Now, the Mach 4 would be achieved for a very short period of time, because the pressure basically would go from, or sorry, the speed would go from Mach 4 and drop basically. So if you're testing something at Mach 2, you'd basically wait till it drops to about Mach 2, or start it slightly lower, and then you could take all your photographs and look at the effects of all the shock waves and so on coming off the item. And we do know that things like the ramp air intakes for the Concorde were tested in there. And if we turn around, you can actually see this is the valve, basically the fast moving gate valve, which is how they sealed it initially, and when they wanted to test, that would come out the way as a valve very rapidly, and you get the airflow through into this stub. Unfortunately, so the other parts don't exist at the moment, but if we do walk through quickly here, when we turn the lights on, we can actually see the last remaining part from what was in this room, which is now known as the Vickers suite. So now we've got the lights on in here. This is the area where the tunnel section for the wind tunnel existed, and the experimentation kit would have been in the middle of the room here. And we know partly how it was arranged, because there's evidence still in the ceiling. There's basically some I-beam in the ceiling that goes around as a rail, and that was the rail that supported a hoist. And that hoist allowed you to move heavy parts around to like Venturis and so on, which could be then put into the test chamber or elements of that, which allowed you then to modify the airflows and things. Now, that's the only bit that now remains, shall we say, of what was in here. But also, there are other evidences in that in the wall here we do have some relief valves. So to prevent potential for overpressure, as you're releasing the balloon, you have these flaps which could open. So as you were basically, if there was a lower pressure outside there, you want to be able to let more air through, to otherwise you could be restricting the balloon. So you have 4 here of basically relief valves, and I think they all basically still work, so they'd have been flapping around like that. And finally, outside is the last bit of pressure relief or protection. There's this item here. So that was there basically to act to stop overpressure. So basically this thing could flap open if necessary, if there was an overpressure system created. So this is still the building where the balloon hangar used to exist, and inside we have some very thick walls which are there to support the pressure, and inside there now we have the McLaren exhibition. So we've just come through this door from where we were in the Vickers suite, and the point of coming in here, which is now the McLaren display, is to look up. So as one looks up, we have the simulation of a balloon. So this is where the balloon hangar was, providing the pressure for the supersonic wind tunnel. Now, it always does occur to me, I think the balloon ridges are the wrong way round, because this should be overpressure, but given that, it gives a sort of illustration of how it might have been, because this was a barrage balloon, as far as I'm aware, is what they used, which would have filled the whole of this area and provided the air pressure to go through into the chamber of the vacuum and create the up to the Mach 4 wind speeds. So let's now move on to round the front of the chamber, where we can see the whole full chamber itself. So now we've come from the supersonic wind tunnel, and in passing I thought I might mention this cabinet here, which is the control gear for the high-speed gate valve, and there's a whole load of pipe work. There is also a whole load of missing pipe work, so we can't quite work out how some of it worked, but fundamentally there's a very high pressure device over there which creates extremely high pressure, which allows the gate valve to be moved very quickly out of the way, which is what you need when you're trying to create a Mach 4 flow for 40 seconds. But as we then move back from here, we are now in the front area of the chamber itself, and as we pan slightly to the left, that is now the full picture of the mating parts from the door. And you can see the large circle in the middle, which is the 25-foot diameter chamber, and it's about 50 foot long, and the 4 pipes which are ducts around the side where the air was basically circulated or recirculated. The door itself is the black object to our left. So the door would then slide, or roll should I say, on the rails which we have here, and we did see the bogies underneath. So the whole thing would slide along here and across, originally all manually powered. However, later on there was a motor added, and I think they could do it in about half a minute once they got going, shall we say. I think stopping it was probably more of a problem, and there are various different micro switches around the place which would be able to detect when you're nearly there, to hopefully not overrun too much, or else you would have probably run straight through the buffers, as it were, at the bottom. So what we have here is, as I say, the main chamber, and if we walk up into the chamber, you have this platform. The platform basically forms the floor of the chamber when you're doing normal sort of work, and we saw a little bit at the back where there was a lower airlock. The upper airlock is at the back, at the front, behind the model here, or the section should I say, of the Vanguard, and we saw the back end of that section. So in here, once the door had been closed, you would start removing air if you needed to. You could also start cooling it down. So inside here, as we said, we could get down to minus 65 Celsius and 0.05 of a bar. Now that's equivalent of 70,000 feet. And over the years, I don't think they did those extremes very often, but certainly in latter days, it was used far more as an environmental chamber. So you could create almost any weather conditions you wanted from around the world, up to a 45 knot gale, and you could go very cold or quite hot desert conditions. You could recreate things like sun. So we saw a picture up in the control room. Basically you could put UV lamps on things to simulate desert type conditions in hot conditions. And over the years, a lot of bits and pieces were tacked on literally to the walls. So here, for example, we have these sections which were designed for planks. So you could get on and walk around where we are standing, which would have, when they're doing the trawler experiments, would have been a big puddle, big pond, whatever you want to call it, a bit like a swimming pool. But anyway, you just put barriers at the front and the back, and then fill it up, tarpaulin type at the bottom, and you could fill the whole of this with, as we're seeing the pictures on the video up there, those are some pictures that were taken here. And in the background there you can see some of the planks and the water being circulated. And when you see the ship itself, when you get through the words, it takes its while. You could do that basically. So this is part of being able to put 1.5 ton to 2 tons of water in and spraying it through in very cold conditions. You could ice up a big model and capsize it. You could then work out what was causing the problem in terms of the amount of ice that there was on the rigging. So that's quite a famous experiment that was done in here. But through the years, right the way through to early 1980s, it was used fairly consistently, constantly. The last thing that was tested in here in 1981 into 82 was a gate assembly for the Thames Barrier, where they were looking to icing conditions, because they were concerned that the gates needed to continue to work in the most extreme winter type conditions. So that could be icing, fog, or even driving snow and ice. And what you didn't want to do is not be able to shut the gates when you needed them. So I say that was the last thing that was ever tested here. And through the years, there was hundreds of different things, many of which are little known about, because at the time the activity probably was secret in terms of the development of the military kind of kit. Okay, so we have pictures here, mannequins showing some of the garb that they might have used to get in here when it was cold, for example, over there. And also when it was wet, in terms of having wellies and sort of kits that allowed you to resist, shall we say, the effects of all the water and so on you could get in here. And again, I'm told of a story where one of the guy, Mr. Kirby, was as an apprentice failed to stand back quick enough, and he ended up coming in here when they were testing some dinghies in Arctic freezing conditions, and there was a set of them in the dinghy, and basically they were said, tell us when you're getting too cold and you need to get out, and which is basically trying to look at whether the kit that they had designed was adequate for pilots that might have ditched. And he says that they got to the point where they really couldn't stand it anymore, so they got on the radio or whatever communications they had saying, please get us out of here, to which the people in the control room said, okay, fine, we'll be with you in 20 minutes. I'm not sure they were that pleased at that point in time. But anyway, that's the kind of kit that they would have used in here, and many experiments were done in here. And as I say, that really is the chamber itself. The only other point to maybe note is this door here. This is actually the end of the supersonic wind tunnel. So when that was taken off, you had the access to the wind tunnel that came through from the balloon hangar. And when it's not required, they sealed it off to stop leaks. So that was about 1958 when that was put in. But we've probably been around most of it in here. One thing I would say is, if you look on various YouTube and other areas, that we've done quite a few other videos in here covering more details of the chamber itself, going to areas we can't normally get to, like underneath the door, the electrical supply system, and a few other areas. And also there's various videos done by my colleague Andy Jordan, who's done things about the bombs over there and the engines that you might have seen passing on the way round. We have quite a lot of people who actually do work around here, and most of us are around on a Wednesday afternoon, so if you're free on a Wednesday, please come in and we'll be pleased to talk to you and take you around and show you more of what there is to see here. So for the moment, that's thank you for coming through and lasting to the end of this video. And so it's goodbye from myself, John Rowland, and hope we might see you again sometime.